My name is Marlon Rugama. In today's video, I'm going to show you how to solve a DSA challenge that I got from an iOS senior interview. That's iOS senior position. I had this interview last week, so let's start by defining the problem or the challenge. So here we have a function, it's called trace. The trace is basically determined based on the action it takes. What kind of data structure is being performant. Let's say you to take actions. The actions, if we go to the definition of the action here, it takes two actions. The number one is insert a number in a list, and then the number two is popping the number. If we see the definition of data structure here, we have stack, queue, and priority. So stack means you have the list of elements or items. So when you remove the last element in the list, that is in a stack data structure. Is that the definition? Also is also known as LIFO or last in, first out. And then we have the queue. The queue is when you remove the first element in the list. It's called also FIFO, first in, first out. And then we get the priority data structure, which is just the smallest element in the list. So let's go over the some like eight cases. Here, when you provide an empty action into the trace function, so you expect an empty set. As a result, when you try to pop or remove from the list an element that you haven't inserted yet, so you return an empty set. When you insert and you only have one element in the list and you pop the element in the list, that element is going to be the first element in the list. It's also going to be the last element in the list, and obviously the smallest element in the list. You don't have any other element in the list to compare with. So you return all of them. So the next one is you are popping, if you are three operation of insert and then one operation of or one action of pop. But this pop is the first element in the list, so you return a queue. And this pop, we repeat the same actions and we just pop the last element, you return the stack. So, and then you say, okay, I'm gonna pop the smallest element in the list. So you get a priority. What happened when you are you insert, and then you pop an element you haven't inserted yet? So you return an empty set. And then you insert, and you remove the last element in the list, but it turns out that also is the smallest element in the list. So you return priority and you return stack. And then you insert and you right away pop. No matter how many times you repeat this operation, you need to return all of them because it's the same each case of the number on line 19. Okay, so let's go ahead and try to solve this problem. I'm gonna copy the function here. I'm gonna paste that in here. I'm gonna try to see if indentation is working. So we have some issue here, some like an error from the compiler because we haven't defined the action and we haven't defined the data structure. I'm gonna define the action as an enum type action. And we have a case of, if we go here in the action, we have insert and we have pop. And we insert what? A number, right? So I'm going to represent the number that we insert as an integer. Here, when we pop, we also pop an integer. So I'm going to copy the data structure here, and I'm going to represent the data structure also as an enum. Case we have stack, queue, and priority. Stack, queue, and priority. Okay, and then I can go ahead and implement the solution here, but let's just like make a pause here. I'm gonna uh, I'm gonna implement this by using the TDD approach. The TDD approach is basically test-driven development, and we are gonna write some tests here in order to uh, make sure that our solution works. So I'm gonna go here over all of these 8 cases. Um, I'm gonna move the test all the way up here for now. No, I'm gonna keep it down. The last thing I'm gonna do is just print all tests passed, and then we can use assert. We have two assert. We can two initializer, but we can print out like a message when the test fell. So I'm gonna use it with a message. I'm gonna call here my trace function. It take actions, but we are gonna provide an empty action. And we expect here empty set. So the message is expected empty set. So, and then we provide just one action is pop. It's also expect empty set. So this second assert is gonna be a pop action here, and it's 200 or 500 or any number here. So we expect also empty set. And for the third one is I think you add or you insert and you right away you pop. So if we provide this one, you expect all of them because you are inserting and removing, and you are removing the first element, the last element, and the smallest element in the list. So you expect all of them. Expected is all data structures. I'm going to copy this, and I am going to try to solve or try to write the test for this one. We are here popping the first element in the list. So if you insert, you copy here all the actions, we are expecting the queue here. And now it's going to be a stack and then priority. So I'm going to copy. So here I'm going to copy this one. I'm going to paste it and paste it. So here you are popping the last element is going to be number 3, and here you are popping the smallest element is going to be number 2 here. So this is in stack, and this is priority stack and priority data structure. Okay, so we are in the priority, and now you are trying to pop an element you haven't inserted yet. So I'm going to copy this one. I'm going to say just here 200, and you expect empty set. Okay, so we are here, and then we try to pop the last element in the list, but also it turns out that this is also the smallest element in the list. So I'm gonna copy this one. I'm gonna say here, I'm gonna copy this one here. So we are like trying to do a priority and also stack, I believe. So priority and stack data structures. And then we are inserting and popping right away. So I'm gonna copy this one and remove, copy this one and override the actions here. We are expecting all of them, and then we expect all of data structure here, copy the message and paste the message in here. Okay, if we run the test, the first is gonna pass. The second is gonna pass because as you see here, you return empty set. No matter what, you haven't implemented anything, but you return, or the function is gonna return the empty set. So it's gonna probably fail here in the number third here. So let's try and see what happened here. Line number 46, I believe is gonna fail. Yes, line number 46, assertion fail. Expected all of data structure is this one. Oh, is this one, I'm sorry. Excuse me. Okay, let's go ahead and implement this. The first thing I'm gonna do is I'm gonna return my trace. I'm gonna declare here my traces, and this is gonna be a set of data structure, and we initialize my traces. This when we can do this, or we can also say here is gonna be a set of data structure. So here we are like defining the type, or here we are inferring the type. So this is called type inference. Okay, so we can return here instead returning an empty, we can return the trace. Okay, so but let's loop on the actions. So we have action here, and we say for each, and we have action. This action is an enum. The best way to iterate with enum is using switch. So I'm gonna go action. We have two cases here. We have one for insert. I'm gonna call this value. And where are we inserting to? We are inserting in our list. This is a list of integer, and we are gonna initialize this. So insert in the list, and we append the value. And then we have another case for pop, and we are gonna call this value as well. And let's just break the loop for now. So let's think about this. Okay, what happens if you take an empty action? So before doing anything here, I am gonna use an early exit guard statement in where we make sure that the action is not empty to continue evaluating here. If this is the action is empty, we return just empty set. Okay, we already covered this one. What happens if you are trying to pop, but we haven't inserted anything in the list? So here we can say guard. You're popping right now, so we can say as long as the list is not empty, you can continue evaluating. Otherwise, it's just gonna, we are in a loop here of it. So we just break the loop We don't want to continue looping. Just exit. Okay, we already covered this one. And now we say, okay, we insert, we pop the first element in the list. So right now I can say here, Agarlet first item in my list is going to be first. What will happen here? So, oh, sorry. If we are able to fetch the first element, so continue doing the operation. So now we need to compare if the value that we are trying to pop is equal to the first element in the list. You guessed right. This is a queue data structure. So in my trace, we insert the queue. Okay, but also, as you see here, my first element in my list is also the only one element, is also my last and the smallest element in the list. So after we insert here in the trace, we need to remove from the list the first element. Remove at the first element. Okay, if you don't have more element in the list and you're removing the first element in the list, so we need to make sure that the list, if the list is empty, we are gonna add in our trace the priority and the stack. Okay, and then we say we break. Otherwise, this is just the first element in the list, but it's still the list has still more like items. You can just break here as well. Okay, and now we can do the same for the last element in the list. So we can say here, car last item is equal, oh, let last item is equal to last. Okay, ah, I always do this. If you can take the last item, continue the, otherwise just break. Okay, so if my value, that my pop value here is equal to my last item, we say here trace insert. This is a stack. Okay, and now we can just break this. Okay, but now in the middle you can have also like your the smallest element in the list. So you need to make sure that we we can declare here the smallest item. We don't know yet what this number is gonna be, so I am gonna use the integer max number. And also we will need to know where this item is located in the list, so we can call this smallest item index. Since we don't know this index is gonna be found in the list, we are gonna call this, we are gonna mark this as optional. Okay, and then we loop the list with, I'm gonna use for, I'm gonna use index, I'm gonna use item in the list. To get the index and the item, we can use the operator enumerated function. The only thing that we need to make sure here is this smaller number. If item is smaller than this smallest number, so we say smallest number is equal to item. And now we need to know as well if the we need to know as well the index. We need to know the position. Okay, so index. So here we need to make sure that we have here if the value is equal to the smallest item, so in the trace, we can say here insert, this is priority. And in the list, we can say remove at index, smallest index, smallest item in the index. Since this is optional, so we need to make sure that the index unwrap this safely. So instead using the optional, we can use just the index here. And then you can break the loop. Okay, but what happened here if the last element is also the smallest element in the list? So I'm not gonna break here. I'm gonna, instead breaking here the loop, I'm gonna make sure that the last is gonna be the smallest element in the list. If that is the case, here I am gonna go ahead and say traces, insert, and this is gonna be priority. And then here we can break because we know that the last element in the list is also the smallest. We don't need to evaluate this anymore. But I believe this worked. Let's go ahead and run the test one more time. Yes, it worked. So thank you for watching this video. I hope it's helped. Sorry for my pronunciation. English is not my first language, but this is not an excuse to expose myself and show my coding skill. So thank you once again. Bye.